All right, in the last lesson, we took a look at the power rules for derivatives, knowing that if I had f of x is equal to x to the n, then f prime of x is going to equal nx to the n minus 1. With the sum and difference rules, if both f and g are differentiable, then so are f plus g and f minus g. So the sum rule states that f plus g prime is the same as just f prime plus g prime. If f minus g is prime, then it's f prime minus g prime. Now, let's try and apply that. If I'm taking the derivative of x squared plus 12x to the 5 minus 4x to the 4 plus 10x to the 3 minus 6x plus 5, then I should be able to take the derivative of all of these terms individually and combine them. As we see here, the derivative of x squared, the derivative of 12x to the 5, the derivative of 4x4, of 10x3, of 6x, and finally of 5. So the derivative of x to the 2 is just 2, x to the power of 1, or just 2x, plus 12 times the derivative of x to the 5 is just going to be 5x to the 4, minus 4, and this is going to give me 4x to the 3, plus 10, and I'm going to have 3x to the 2 minus 6, and then remember the derivative of a constant is just going to be 0. This is going to give me 2x plus 60x to the 4 minus 16x cubed plus 30x squared minus 6. Or when I put it in descending order by degree, 60x to the 4 minus 16x cubed plus 30x squared plus 2x and minus 6. If I'm using the same process for function f of x is equal to 2x to the 4 plus the square root of x, then that means that I can also state that f of x would equal 2x4 plus x to the 1/2, which means that f prime at x is going to equal 8x to the 3 plus 1/2 x to the negative 1/2, which is the same as 8x to the 3 plus 1 over 2x to the 1/2, or 8x to the 3 plus 1 over 2 and the square root of x. When I take a look at b, if I'm given 2x squared minus 3x plus 4 over the square root of x, then that means that f of x is equal to, because these are all being divided by the square root of x, 2x squared over the square root of x minus 3x over the square root of x plus 4 over the square root of x. That would give me 2x squared and then minus 1/2 because of the square root, minus 3x minus 1/2. And remember, we're doing 1 minus 1/2. And then finally, just plus 4x to the negative 1/2. And when I simplify that, what am I left with? 2x to the 3/2 minus 3x to the 1/2 plus 4x to the negative 1/2. Now I can use that to solve what my f prime of x is going to be. So I'm going to have 2 and 3/2. And when I take away 1 from 3/2, I'm going to have x to the 1/2. Minus 3 and 1/2 x to the negative 1/2 when I take away 1. Plus 4 and negative 1/2 x to the negative 3/2. Or 3x to the 1/2 minus 3/2 x to the negative 1/2 minus 2x to the negative 3/2. And I can state that as 3 and the square root of x minus 3/2 and the square root of x minus 2 over x to the 3/2, or the square root of x cubed. If I'm determining the differentiation of x times x minus 1 squared, the first thing that I'm going to do is I'm going to expand it out. So d over dx and x times x squared minus 2x plus 1, which is also going to be the same as d over dx of x cubed minus 2x squared plus x. And this is going to give me 3x to the 2 minus 4x plus 1. For example B, if I'm doing the differentiation of x minus 2 over the square root of x squared, then I'm going to say that this is going to be the same as d over dx of x minus 2 and x to the negative 1/2 times x minus 2 x to the negative 1/2. Or d over dx of x squared minus 2x to the 1/2 minus 2x to the 1/2 plus 4 x to the negative 1. Simplify it, and I'm going to get the differentiation of x squared minus 4 x to the 1/2 plus 4x to the negative 1s. Well, the differentiation of this is going to be 2x minus 4 times 1/2 is going to be 2. And x to the 1/2 minus 1 is going to be negative 1/2. Minus 4, x to the negative 2. Or 2x minus 2 over the square root of x minus 4 over x squared. When I get to example C, then I'm going to state that this is d over dx of, because this is all being divided by x and the square root of x, I'm going to rewrite that as x squared minus 3x minus 5 is all being divided by x to the 3 over 2. Which means that this is d over dx of x squared over x to the 3 over 2 minus 3x over x to the 3 over 2 minus 5 over x to the 3 over 2. And this, because it's constant, is actually x to the 0 when I am subtracting these, which is going to give me d over dx of x to the 1/2 minus 3x to the negative 1/2 minus 5x to the negative 3/2. When I do the differentiation, that's going to give me 1/2 x to the negative 1/2 minus 3 times negative 1/2 x to the negative 3/2 plus minus 5 times negative 3 over 2 x to the negative 5/2. Or 1 over 2 x to the negative 1/2 plus 3 over 2 x to the negative 3/2 plus 15 over 2 x to the negative 5/2. This is going to be equivalent to 1 over 2 and the square root of x plus 3 over 2 and the square root of x cubed plus 15 over 2 and the square root of x to the 5.